Hello students, how are you all? I hope all of you are doing fine at home. So in today's video we are going to see some more about magnetic effect of electric current. In our last video we have studied about the magnetic effects. What are the magnets? All these things we have studied in our previous video. So in today's video what we are going to study? The topics are, first one is magnetic field due to current carrying conductor. Second is magnetic field due to a current through a spring conductor. Then we'll go for our right hand thumb rule. So let's start the video. The first one. So first one is that the magnetic field due to the current carrying conductor. Suppose I have a conductor through which current is flowing. So it will create a magnetic field around it. If the current is flowing through it. If I will connect this one with some battery or a power source, so it will create some magnetic field around it. So here what the shape will be, the magnetic field will be like that. So as you see in our previous video, we have a bar magnet. Its shape is rectangular and we found the magnetic field is like this. So here if a conductor is there, so it is like this, and if you have a horseshoe magnet, then it is also having some different types of magnetic field around it. So you should remember the shape of the object is how the magnetic field will be like that only. So to find out what the actual this one is, so let's go for some activity. In that activity, what I will found, I can easily observe the direction of the magnetic field, how the magnetic field looks like. So for this, let's do some experiment. Suppose I will take some power source, let us suppose 3 batteries, then it is connected with a key, then I will come here like this. Okay, so this is the circuit. For example, when the key is on and current is flowing through it, you all of you remember the current is going from positive to negative or no? Suppose the current is going from positive to negative in this direction. So what I will do, I will place a magnetic needle above it. I will place a magnetic needle above it. Suppose the middle is like this. Okay. So I place a magnetic needle above it. So how the direction will be, how it will be, that we are going to see in this video. So let's find out. As you know that if I draw like this, this is my north, this is my south, this is my west, and this is my east. So when current is reaching at this point, so current is coming here in this direction or not? So here you can see it is coming from north to south. North to south. So here there will be a deflection. So all of you know that when current is flowing through a conductor, this is a conductor or not, through which current is flowing. So when the current is flowing this one, so definitely it will create a magnetic field around the conductor. So from there we can easily find how the direction will be. So always remember, when the current is flowing from north to south, at that time the deflection will be towards the east. This is my normal position. It is normal position, but when the current is flowing, so the position will be changed. It will be like this. Means the direction, the magnetic needle will change in direction towards the east, where the current is flowing from north to south. So don't confuse with that. The current is flowing from positive to negative. When it reaches here, this is the north direction, this is the south direction. So when the current is flowing from north to south, the magnetic needle will deflect towards the east. This is the east direction, it will deflect towards the east. If I reverse the current, means what I will do? I will do like this. This is negative, this is positive, this is negative, and this is positive. Now you see the direction of the current is in this direction. Same direction, same diagram, only the direction of the current will be changed. This is positive, this is negative, this is positive, this is negative. Means the current is flowing in this direction. Here is my, let's keep the key here. Now you see the current is flowing in this direction or not? I will place my magnetic needle here. So when the switch is off, the direction will be like this or not? Towards north and south, as I studied in the previous video. So this is north and this is south. So when the current key is on and current is flowing, as you observe, the current is going from this point, the current is going in this direction. It means it is going from south to north. It is going from south to north. At that time what will happen? The deflection will be towards the west. Means the direction of the needle will be like this. It is deflected towards west. So you should remember, when it is going from south to north, it is deflected towards the east, and when we are going from south to north, and that direction will be, deflection will be towards the west. This is how you find the direction of your magnetic field. So now let's go to the next topic. In that topic you can easily find out how the magnetic field will create if I take a straight conductor. Here in this topic what we are going to study, that how the magnetic field create around a straight conductor. So what is a straight conductor? Suppose it is a straight copper wire through which current is flowing. So this is called a straight conductor. So what I will do, that I can easily find the direction of the magnetic field create around a straight copper wire or a straight conductor. So just let's say take a small drawing board. In that drawing board I will fix my copper wire, and here I will fix a white paper. I will place a white paper here. Now what I will do, I will attach this straight conductor with a rheostat, a key and a power source, that is a battery or any power source. After that what I will do, I will sprinkle some iron fillings around it. You observe here the switch key is not on, means is not closed. So when I close the key, means current starts flowing. So all of you know that this is positive, this is negative, this is positive. So definitely current I will flow through it like this direction. It will go from this direction and like this will go. So how the magnetic field will be? So after a few minutes what I will observe, that there is a small ring-like structure is creating around it. Small ring-like structure is created. So what I will do, I will simply tap on the board. I will tap on the board. So when I tap on the board, what I observe? I observe that small circle-like structures is creating around it. Circle-like structures. These are called concentric circles. You can see this is called concentric circles. Will create around it. So how I will find the direction? If I place a magnetic needle here, suppose I place a magnetic needle here. So as you know that when current is flowing through this direction, so how the direction will be? So my magnetic needle will be deflected like this. Will deflect like this. Because the current is flowing through it and the direction will deflect like this. So how the deflection create and how the direction will be, that we are going to observe in our next topic. The next topic is Maxwell's right hand thumb rule. That's called Maxwell's right hand thumb rule. So what this thumb rule is telling us? So it's a very basic concept. Let's have a small activity. Maxwell's right hand thumb rule. So what is this all about? So this is all about, suppose this is my straight conductor. This is my straight conductor, and I am holding the straight conductor like this, and it shows the thumb. This shows the thumb. This shows thumb is towards the upward direction, and you see my fingers are wrapping around it in that direction. So this is the direction of our magnetic field. Means if the conductor is placed like this and the direction of current is towards the upside, so definitely around it magnetic field will create. Magnetic field will create around it. So when I observe, what I observe? This is the direction of magnetic field, and I am wrapping like this. So it means this shows the direction of my current. This finger point was the direction. Similarly, when the current is going downward direction, this is current is going upward direction, and here the current is going downward direction. So what I will do? I will hold my conductor like this. So at that time, this is the direction of current, and this is my finger wrapping the conductor. Means this is in that direction. So again, here our magnetic field will create like this. So here, what I found, like this, current is going in this direction. So the current will be in this direction. So this is called Maxwell's right hand thumb rule. So what this thumb is doing? If the current is going upward, so the finger wrapping the conductor, that is the direction of magnetic field. If you do like this, then this is the direction of current downwards, and this is the direction of magnetic field. With this, I am concluding this video, and we'll continue the next video. Thank you.